If you've ever seen a hurricane, hopefully in just a picture, not in real life, then you'd probably know that it kind of pulls things around and towards its center. If a ship is a safe distance, all it takes is a simple change of direction to avoid the strong pull. But say that ship failed to swiftly move away, the strong pull of the hurricane might get the best of it. Kind of fascinating, huh? Well, out in space, there's something just like a hurricane. It's called a black hole. The nearest black hole is quadrillions of miles away, and it would take years, even going at the speed of light, to get to it. That's pretty, far out. When a star is big enough, it'll run out of energy and transform into a supernova. This takes a course of usually billions of years, but when this does happen, something called fallback occurs, where the star implodes. If it is large enough, the implosion will densify the now reduced star, and it will still have all of its gravity and form a black hole. Yes, that's right, a black hole is just a dense imploded star with very intense gravity. In fact, so intense that nearby light cannot escape it. And light is pretty fast. More specifically, it travels at about 186,000 miles per second. No, this speedometer does not measure in miles per hour. We're talking seconds. Look at it this way. When you turn on a lamp, it illuminates the surface immediately. That's because it doesn't take long for the light to travel to its destination. However, from the Earth to the Sun, it takes about 8 minutes for the light to get here. That means the light we're seeing is from 8 minutes ago. Well, anyways, you get the idea. Light is pretty fast, but not fast enough to escape the grasp of a black hole. And like Mr. Einstein said himself, nothing is faster than light. Basically, that means once you're in a black hole, you're kind of screwed. But while you're in there, here's a fun little experiment you can try. Call up a friend and ask him to lend you an apple. You know, because you gotta eat. As the apple is being thrown to you, watch it come into the black hole's orbit. It will change colors as it comes closer, cycling through the spectrum. Why does it do this? Well, the explanation is simple. As the apple goes through different gravity zones, the light has been manipulated. But I'm just kidding. This wouldn't be possible in the first place. On the inside of a black hole, your matter would be like clay, bent and stretched out around the gravity. When the gravitation of a black hole is drawing you forth, it also distorts and bends you towards the center. And if you could feel the pain, it would be like being played tug-of-war with, except you probably wouldn't feel it because you'd be dead. But on a less pessimistic note, most things that enter a black hole are just nearby stars. Of course, like the whirlpool we were talking about earlier, it has a safe distance too. But once you get in too far, there's no going back. This leads to a question that many have wondered. Where does everything in a black hole go? Well, nobody really knows for sure. Personally, my theory is that everything held in its gravity gets compressed into the void that is the black hole and doesn't really go anywhere. But it's just so small that nobody can see it. But who knows? It could go into a parallel universe, it could be locked away forever, anything could happen. The reason a black hole is, well, black because it doesn't generate light, nor does it reflect any. All the light is trapped. The light around it is simply the objects its gravity are absorbing. A black hole is just a dense imploded star with lots of gravity. In fact, the center of every galaxy is a supermassive black hole, in theory that is. Nobody knows how supermassive black holes are made either, because that would require a star this, well, supermassive. To get an idea of just how massive we're talking, a galaxy holds billions of stars all held together by this supermassive black hole. Once again, that's just a theory. This would require a fallback of a star with the mass of billions of normal-sized stars combined. Seems unlikely, doesn't it? This is why nobody knows for sure how black holes ever get this big. But hopefully you've learned something today, even though our primitive human knowledge is the limit to some of the theories and unknown properties of a black hole. But anyways, thanks for watching.